A question from binomial theorem, the smallest natural number n such that the coefficient of x in the expansion of this is nc23, then what is the smallest value of n? So, let us see again an easier one, the coefficient of x. So, first I am writing the general term, it is NCR x square raised to the power n minus r 1 upon x cube raised to the power r. Now, collecting the powers on x, we have 2n minus 5r, here it is NCR. Now, this value has to be equal to 1 because we are here to find out the coefficient of x. So, 2n minus 5r is equal to 1, and also it is given that the coefficient is NC23, and here we are having term NCR. So, definitely you can relate this. So, straight away R can be 23, and for R to be 23, if you place it here, you will get N is equal to 58. Now, there is one option that is 58, but just hold, just wait, because we are asked to find the smallest natural number. So, we also know NCR is same as NCn minus R. So, definitely this value which is 23 can be also n minus r. So, n minus r can also be 23, and if you solve this equation and this equation, you will get another value of n which will be equal to 38. So, definitely this is an error prone or the mistake prone problem which will actually give you answer 58, but you need to check it once again. The smallest value is not 58, it is 38. So, definitely third is the correct option. So, let us move to the next problem. The next problem is on stats, and it is given that the mean and SD standard deviation of 50 observations x1 up to x50 are equal to 16, then what is the mean of x1 minus 4 whole square, x2 minus 4 whole square, and so on. So, the problem is related to data, and we can see number of variables here, but if you write the data properly, you can see this is an easy problem. So, first let us see what is given to us. It is x1 plus x2 up to x50. The mean of these is 16. So, we can write this as 16 into 50. So, let us treat this value as A. Again, the SD is given 16. So, we have 16 square is equal to x1 square, x2 square, x50 square upon 50 minus 16 square. You know the formula related to SD. So, from here we have B, which is equal to sum of square of these data up to x50. So, this is equal to, if you take 16 square here, you will get 2 into 16 square into 50. So, let us treat this value as B. Now, what we have to find out here, let us see the mean of x1 minus 4 whole square, x2 minus 4 whole square, and so on up to 50 observation. So, this is what we have to find out. If you expand the numerator, you will see you will get x1 square, x2 square, and so on, that is you will get the value of B. So, expanding the numerator will give you B, and again you will get minus 8x1 minus 8x2 minus 8x3. So taking minus 8 common, it will be the sum of x1, x2, x3, which is actually equal to a. And again one more part, 4 square again from the 50 terms that sum up to 4 square into 50. So upon 50. So this is what we have to find out. You know the value of a, you know the value of b. If you put a and b here and you know all other values, you will get this value, that is the mean, equal to 400. So the point was simply writing the data in a correct way and then calculating the required mean. So again an easier one. Let us move on to the next problem. Next is an easier problem on the indefinite integral. It is this one. Now again a simple substitution is needed here to evaluate this. Now it is given that this integral, it is equal to gx into e raised power minus x square. So what can be done here is by simply substituting minus x square is equal to t. You can see this entire integral is easily converted into t. So from here we have minus 2x dx is equal to dt. So this can be easily replaced in terms of dt. So it is basically minus half t square into e raised power t dt. Now the integral by parts you can apply here because there are two different functions. So integrating by parts, we have the integral as minus 1 by 2 e raised power t square minus 2t plus 2. Now replacing again t with minus x square, we have minus 1 by 2 e raised power minus x square x raised to the power 4 plus 2x square plus 2. Now if you compare this entire function is gx. So gx here is minus 1 by 2 x raised to the power 4 plus 2x square plus 2. The value of the gx at minus 1 is asked here. So if you put x equal to minus 1, this will be equal to 5. So this value comes out to be minus 5 by 2. So the option which is correct here is the fourth one. Let us move on to the next problem.